Hey everyone, and welcome back for another deep dive. Today we are looking into LIMO,
LIMO.
which is
Less is more for reasoning.
less is more for reasoning. Yeah, and I think this is super interesting because, as you know, a lot of AI, especially in like mathematical reasoning, has really been focused on huge data sets.
Yeah, absolutely. The idea has always been that you need as much data as possible to get the AI to learn properly.
Right, and it seems like LIMO is like bucking that trend.
It really is kind of turning things on their head.
So what is LIMO? What is the LIMO hypothesis?
Well, it kind of comes down to this. If an AI model already has a really strong foundation of knowledge,
Okay.
from pre-training with huge amounts of data, it doesn't necessarily need tons more data to learn how to reason.
So it's like it already went to like AI elementary school.
Exactly. Like it already has the basics. And
Yeah.
then instead of just like shoving more and more information at it,
Right.
you can use a much smaller, more carefully curated set of examples.
So what does pre-training actually look like?
It's kind of like if you were learning a new language, you wouldn't just jump into reading like really complex novels, right?
You start with the alphabet.
Exactly. You'd start with the basics grammar.
Right.
Simple vocabulary.
Yeah.
Yeah, and it's the same with AI. Pre-training is like giving it that initial exposure to a huge amount of general information.
Like text code.
Text code, mathematical concepts, all kinds of things.
Gotcha.
And it's this base level of understanding that allows them to build on.
Okay, so that makes sense. But then, so LIMO uses this pre-existing knowledge, but how does it actually use it?
Well, instead of bombarding the AI with just more and more data, LIMO uses these high-quality examples, almost like cognitive templates.
Cognitive template.
Yeah, and these aren't just random examples. They're specifically chosen to show particular reasoning pathways and problem-solving strategies.
I'm picturing like a step-by-step solution to a math problem.
You're on the right track. It's not just about the answer, it's about the whole process. It's like if you were teaching someone a complex puzzle, you wouldn't just show them the finished puzzle, right? You'd walk them through the steps.
Yeah, you'd be like, oh, you have to find the corners first.
Exactly. You'd explain your logic and the strategy, and that's kind of what these cognitive templates are doing for the AI.
So it's like a guided tour through the problem.
Yeah, a guided tour of how to think.
Okay, that makes sense.
Yeah.
But how is it that the AI can learn so much from so little?
That's where the two revolutions come into play.
The two revolutions.
Yeah, so the researchers talked about these two revolutions that made this possible.
Okay.
The first is what they called the knowledge foundation revolution, and that's what we were talking about before,
Okay.
where AI models now have this huge base of knowledge because they're trained on so much data.
Right.
And then the second revolution is the inference time computation scaling revolution.
Okay, now that sounds a lot more complicated.
I know it's a mouthful, but essentially it means that AI is getting way better at handling those really long, complex chains of reasoning. Like, think about it trying to solve a complex math problem in your head versus on a whiteboard.
Right. Having that space to write it out helps.
Exactly. It makes a huge difference. And inference time computation scaling is like giving the AI a bigger whiteboard, allowing it to really explore and work through more complex lines of reasoning.
So it has the knowledge and the processing power.
Exactly. And when you combine those two revolutions with the idea of these cognitive templates, that's what makes LIMO so powerful.
Gotcha. So we've also talked about this idea of less is more for alignment, or LIMA.
Right, LIMO.
How is LIMO different from that?
That's a good question. They both show how powerful using less data can be, but they're tackling different things.
Okay.
So LIMA is mostly focused on making sure the AI's communication style lines up with what we like and understand.
So making sure the AI has good manners.
Haha, yeah, something like that, making sure it can talk to us effectively.
Okay.
But LIMO is more about the reasoning part. It's not just about getting the AI to say the right thing, it's about getting it to think deeply and solve problems in a way that's more like how we think.
So LIMO's about the thinking part and LIMA's about the talking part.
Exactly.
Makes sense. They both seem really important. But I keep thinking about reinforcement learning.
RL.
RL. Yeah, we've talked about that a lot on the show.
Yeah.
So where does LIMO fit in with that?
It's a good question. Traditional RL is often compared to like throwing the AI in a maze and being like, okay, go find the cheese.
Uh-huh. Right. Just wandering around.
Yeah, lots of trial and error can be really computationally expensive.
Just got to try everything until something works.
Pretty much, but LIMO is a lot more targeted and strategic.
So it's like giving the AI the map to the maze.
Exactly, or like a flashlight at least.
Uh-huh. Okay. I like that analogy.
Yeah.
But if we're not using massive amounts of data, the data we are using must be super important.
Absolutely. When you're working with less data, the quality of that data becomes even more important.
So for LIMO, like, how did they choose what data to use?
They're really careful about it.
Okay.
It wasn't just random math problems off the internet. They chose challenging problems from all sorts of places.
Yeah.
Textbooks, competitions, research papers.
Wow.
They wanted to make sure it was diverse and complex.
So it was like creating a curriculum.
Yeah, like designing a course for the AI.
That's so cool. And what about the answers to those problems?
Those are just as important. Remember those cognitive templates?
Yeah.
Well, the solutions were written to act as those templates. They weren't just like the answer. They were really detailed step-by-step explanations.
Oh, wow. So it's like having the teacher's edition.
Exactly. Like the perfect tutor's notes.
That's amazing. Okay, but the big question is, did it actually work?
It worked amazingly well.
Really?
Yeah, in a bunch of experiments, LIMO was consistently doing better than AIs that were trained on much larger data sets.
That's so cool. So it wasn't just memorizing answers. It was actually learning how to reason.
Yeah, it was really learning how to think through these problems. And on top of that, it was able to generalize.
Generalize. What does that mean?
Like, it could take what it learned and apply it to new problems that it had never seen before.
So it wasn't just repeating what it was shown.
No, it was really understanding and applying the knowledge.
That's incredible. Okay, so in these experiments, what was it about LIMO's responses that were so different from the other models? Was there anything like really remarkable about how it approached these problems?
Oh, yeah. There were some fascinating things that happened. Like sometimes LIMO would actually question its own calculations and double check its steps.
Whoa, that's great. Like it was double checking its work.
Yeah, almost like a human would.
Wow.
And that ability to do that, to engage in those deep reasoning chains and question itself,
Yeah.
it really sets it apart from other models.
That's amazing. So it's not just about getting the right answer. It's like understanding how you got there and being able to explain it.
Exactly. And that level of self-awareness and reasoning is a huge step forward.
So if we can get AI to do this with math, what could it do in other fields?
Well, that's where it gets really exciting. The potential applications for LIMO go way beyond just math. Imagine what it could do in science, medicine, engineering.
Oh, wow. Anywhere where you have to solve complex problems.
Exactly.
This is so cool. But I feel like we've only just scratched the surface of LIMO.
We have.
So we're going to have to continue this deep dive in part 2.
Looking forward to it.
Awesome. Me too. See you then.
See you then.
And we are back for part 2 of our deep dive on LIMO. So last time we were talking about how LIMO can solve those complicated math problems.
And even double check its work.
Right? Like, whoa, it's questioning itself.
Mhm.
Okay, but now I want to get into what this could actually mean for the real world.
Yeah, absolutely.
Like, let's talk applications. What about scientific research? I feel like that's got to be huge.
Oh, totally huge. Think about fields like climate modeling or drug discovery,
Oh, yeah.
where scientists are dealing with mountains of data. It's so complex.
Right.
LIMO could really help make sense of all of it, find those patterns that we might miss.
So it's not replacing scientists.
Mhm.
It's like giving them a superpower.
Exactly. It's like a superpowered research assistant.
I love that. Okay, but what about education? Like, how could LIMO change the way we learn?
Imagine personalized AI tutors,
Whoa.
powered by LIMO, adapting to how each student learns.
That would be amazing.
Yeah, giving customized lessons, figuring out where a student's struggling.
Like every student gets their own perfect tutor.
Pretty much available 24/7.
That's incredible, especially for subjects like math, where a lot of people get tripped up.
Yeah, LIMO could help break those complex concepts down into smaller steps.
Okay, so this all sounds really amazing, but is there a downside? Could this make AI too powerful?
That's a super important question. We definitely have to be careful.
Right.
And one of the big takeaways from the LIMO research is that data curation is key.
Okay, so it's not just about using less data. It's about using the right data.
Exactly. We have to be selective and make sure that what we're feeding these AI models aligns with what we want.
Like we wouldn't give a kid a power tool without showing them how to use it safely.
Right. It's the same idea. We have to be responsible when we're training AI, especially when it can reason like LIMO can.
Okay, that makes sense. So thinking bigger picture, could LIMO help us get closer to that, like AGI, the artificial general intelligence?
It's the big question, isn't it?
Yeah.
And LIMO's success with math is a huge step, but AGI is more than just logic and equations.
Right. It's like creativity and understanding emotions.
Exactly. It's all the messy stuff that makes us human.
But if we can teach AI to reason like this in math, maybe we can apply those same principles to other areas of intelligence.
That's what's so exciting. LIMO shows us that there are new ways to think about AI learning.
It's like opening up a whole new world of possibilities.
Yeah, and it reminds us that we're still just scratching the surface of what AI can do.
Okay, so before we go too far into the future, let's recap what we've learned about LIMO's impact on the world today.
Okay, so LIMO could revolutionize how we do scientific research.
Yeah.
It could help us make breakthroughs faster.
It could transform education, make it more personalized.
And it reminds us to be careful and ethical when developing AI.
Yes, definitely a huge takeaway there.
Mm.
Okay, so listeners, I am super inspired by LIMO and what it could mean for the future.
Me too. It's really exciting.
But there's one more thing I want to explore, and that's how LIMO could change the way we develop AI moving forward, and what that means for us as humans, living in a world that's increasingly shaped by AI.
Big questions.
Big question. So stay tuned for part 3, where we'll dive into those big picture ideas. And we are back for the final part of our deep dive into LIMO. So we've talked about how it works and what it could do, but I'm really curious about how LIMO could change the whole field of AI development.
Yeah, it definitely challenges some of the assumptions we've had.
Right. Like for so long, it's been all about bigger is better.
Exactly. Bigger data sets, more complex models, more computing power.
It's like an arms race.
It kind of is, and those big approaches have led to some amazing things, but LIMO is showing us that maybe there's a more efficient way to do things.
So instead of just throwing more data at the problem, it's about being more strategic.
Exactly. It's about using that knowledge the AI already has from pre-training and then using carefully chosen examples to help it learn and reason.
Which makes sense, and I feel like that's got to be good for the environment, too.
Absolutely. Using less computing power is definitely a good thing.
Right, and not just for the environment, but if you don't need these massive data sets and supercomputers, maybe that means AI becomes more accessible.
Exactly. You don't need these huge resources to work on AI anymore.
So it's like leveling the playing field.
Yeah, it opens up the field for smaller teams and more diverse perspectives.
That's really cool, but I want to bring it back to our listeners for a second.
Okay.
Why should they care about LIMO and this whole less is more idea?
It's a good question. LIMO isn't just some theoretical thing. It could really change our lives.
Yeah, how so?
Think about it. AI that can help us solve all sorts of problems, that can help us make new discoveries in science, that can help us learn in better ways.
And it can do all of that in a way that's better for the planet and more accessible.
It's not just about building smarter machines. It's about using those machines to help us build a better world.
That's a great way to put it, and I think that's a perfect note to wrap up on.
Yeah.
So listeners, we've covered so much about LIMO today, from how it works to what it could do.
It's been a really fascinating discussion.
It has. But as we sign off, we want to leave you with this one last question. Could LIMO's success in math inspire us to think about less is more solutions in other parts of our lives? Is there something here that goes beyond AI? Maybe sometimes the simplest solutions are the best ones. Thanks for joining us on this deep dive, and we'll see you next time.